Math time with Nick, with Step, with whiteboard, with pen. Let's go. Step 3 question. What do we got? Well, in all of this, we're using P to denote dy dx. Okay, so this is probably telling me that what we're going to do is we're going to try and write second order differential equations as first order differential equations. Now, given that y is equal to p squared plus 2xp, so already as differential equations go, this is non-linear. All right, because I basically get a dy dx squared, and we don't have tools to deal with that. But when it says that, well, how about, how about we differentiate, okay, and see what happens. So y is p squared plus 2xp. Now let's differentiate with respect to x. dy dx is 2p dp dx plus differentiate the x, keep the p, plus keep the x, differentiate the p. Now dy dx is just p, right? Right, and I would quite like dx dp, so let's make okay, so this tells me that minus p is 2 times p plus x dp dx. Okay, which tells me that minus p over 2 times p plus x is dp by dx, which tells me that dx dp is 2p plus 2x over minus p, which is minus 2x over p, which is what we wanted. Now then, what is this? Well, let's solve it. This is an integrating factor question. dx dp plus 2 over px is equal to minus 2. And I think I'm going to times all of this by p squared. Why by p squared? A bit of experience, a bit of really good at doing integrating factors. Try it out, do the whole manipulation for an integrating factor. But if you do that, this becomes d by dp of p squared x is minus 2p squared, which tells me that p squared x is minus 2/3 p cubed plus some constant. Yeah, which gives us, oh, well, let's call it capital A, because that's what they want. All right, check, check. Right, divide everything by p squared, we get their result. And if p is minus 3, x is 2, so that gives me 18. Is 18 plus a, you get a is 0. If x is 2, p is minus 3, that's 9 times 2 is 18. That's negative 27. Divided by 3 is 9 times 2 is 18. P, well, x is minus 2/3 of p, but p is dy dx. Which will give me x is ae, y is ae to the minus 3 over 2x, I do believe. And we're missing a bit of information here. We are missing a bit of information. Yeah, so the issue is by differentiating, I've gone from a first order, because this is essentially a first order differential equation, I've gone to a second order differential equation, which requires 2 bits of info to solve. I've only got 1, so I'm left with a level of uncertainty here. Right, let's see if we can do something similar to deal with that. All right. So we're going to follow the same sort of steps. This is the, funny enough, step way is we're going to show you how to do one thing. It's up to you to adapt it to do the next thing. So P, which is dy dx, is 2p plus 2x dp by dx plus ln p plus 1, using my product rule. Now that's not as much fun as you might think, but it's doable. Now, is there a nice way to do this? How about? Naught is p plus 2x dp by dx plus ln p plus 1 dp by dx. We'll deal with that in a second. So, like the first one, we're going to want to make dx dp the subject. So that tells me that dp by dx is minus p over ln p plus 1 plus 2x. Which tells me that dx dp is minus ln p plus 1 over p plus, no, minus 2x over p, much like previously. We're going to bring that over. All right. That's 2 over p. So again, times everything through by p squared. Same as before, in fact. And that is d by dp of xp squared. Now, we get minus p ln p minus p. So we need to integrate the right-hand side. Let's just remind ourselves how to integrate p ln p quickly over here. The integral of p ln p dp is differentiate, this is my u, that is p squared ln p over 2 minus the integral of p squared over 2, 1 over p dp, so that's p squared ln p over 2 minus p squared over 4. Okay, so we get x p squared is minus p squared ln p over 2 plus p squared over 4 minus p squared over 2. Now, is this roughly what we want? Divide everything by p squared. Yes. Divide, oh, plus a constant, plus a constant. Now, if x is 1, x is minus a quarter, p is 1. So minus a quarter is 0, minus a quarter plus a, which tells me that a is 0. Divide all of that by p squared, I get x is minus ln p over 2 minus a quarter, which is what I want. All right. Divide all of that by p squared. Right, we now want to find y. Now, obviously, we can't, that's a derivative, so let's change things around a little bit. Times everything by 4. Let's create some space. That tells me that 4x plus 1 is ln of p to the minus 2. That tells me that p to the minus 2 is e to the 4x plus 1, which tells me that p equals e to the minus 4x plus 1 over 2. Now p is dy by dx. So y is minus 1/2 plus some constant. And I do believe I do not have the information necessary to find that constant. Just realized in both of these solutions, we don't actually need to worry about this plus c. All we have to do is plug p into here, right, to find y. That's all we needed to do, just sub it into there. So I'll do it for this one. We got a was 0, right, up here. So very, very quickly. And we can do a similar one for part 2, but we can finish off part 1. Well done if you've already typed in a comment and you know what's going on, right? X is minus 2/3 p. I went to the bother of solving that, but in fact we can just plug that into there. Y is p squared, so that's 4 over 9. So we get p is minus 3 over 2x, and sub that back into there. So we get y is 9 over 4x squared plus 2x times minus 3 over 2x. That's minus 3x squared. So minus 3 over 4x squared. Cool. And we can do something similar for this one. There was no need to go through the extra hassle of solving that extra differential equation. Mea culpa. Sometimes you spot these things. Anyway, well done if you spotted that. Drop a comment. See you next time.